Welcome. This is the Understanding and Implementing SDSFIE-Metadata and SDSFIE-Quality webinar, a resource for SDSFIE training. This training resource is designed for all users. There are two recommended prerequisites for this webinar: watching the Understanding the Vector standard and the SDSFIE Portal and Tools Overview videos. The two background training resources listed here are optional, but they may add to your overall understanding of SDSFIE. All of these videos are accessible from the support section of the SDSFIE portal at the URL shown. The overall goal for this training resource is for users to understand how metadata is implemented in SDSFIE. The specific objectives are that the audience gains an understanding of the following: the contents of the SDSFIE-Metadata, or M, standard document, the functionality for SDSFIE-M metadata available in ArcGIS, the metadata style and metadata editor, how to add SDSFIE-V-based content to your geodatabase, or GDB, the relationship between SDSFIE-Q and SDSFIE-M, and how to generate SDSFIE-Q-based metrics about your GDB data that are then inserted into your SDSFIE-M metadata. Note that additional component-specific implementation guidance for the vector, metadata, and quality standards exists, and users should follow what has been specified at the component level. For example, if a user is doing this work for an Army installation, then that user should follow the Army headquarters vector adaptation and the feature type-specific quality assurance plans. The graphic shown here is a representation of how the SDSFIE family of standards relate to the geographic elements of mapped data, using the Fort Buchanan installation as an example location. Starting in the upper left, the portrayal, or P standard, defines how features on the ground are represented on a map by symbology. The vector, or V standard, establishes a common vernacular for features, like buildings, boundaries, and roads, and attributes that describe those features. The metadata, or M standard, captures important information about the data, such as who created it, to what date the content is relevant, how it was created, and when it was published, which is important for the discovery of data and understanding its quality and usefulness. The quality, or Q standard, is a set of procedures and metrics to ensure and measure data condition and character. The raster, or R standard, is a set of guidance and recommendations for acquiring and using gridded data. The endorsed, or E standard, is the set of geospatial standards that are external but complementary to SDSFIE and vetted by the SDSFIE community. All of these standards help fulfill the DoD goal of making installation and civil works geospatial data and services visible, accessible, understandable, linked, trusted, interoperable, and secure, or VALTIS, across the DoD. The metadata, or SDSFIE-M, is a conceptual schema that defines the fields in which metadata content is collected for vector and raster datasets and services. The conceptual schema is software agnostic, and use of the SDSFIE-M implementation schemas is a method for determining compliance and for sharing metadata information between different software systems. The conceptual schema is based on the ISO 19115 series and ISO 19157. It has extensions to address requirements for legal and resource constraint fields, for which the NGA application schema, or NAS, was leveraged, and an expanded entity attribute metadata section given the rich descriptive content defined in SDSFIE-V, namely the definition, description, note, and justification for all element types. The SDSFIE-M metadata style for ArcGIS Desktop and ArcGIS Pro is an implementation of SDSFIE-M in Esri ArcGIS software. With regards to ArcGIS technology, the content of SDSFIE-M extends the ArcGIS metadata format version 2. This allows the user to switch between SDSFIE-M and other metadata styles without losing their metadata, if that is required. The SDSFIE metadata implementation guidance was released in conjunction with the SDSFIE-M document in June 2020. The SMIG provides implementation policy and guidance for the conceptual schema, and, significantly, requires that SDSFIE-M compliant metadata records be created for each applicable SDSFIE dataset. The SMIG took effect after the DISR mandate, Cycle 20-1, and is referenced by the SDSFIE-Metadata and Quality Mandate Memo from the ASDEIND on August 26, 2020. The required component metadata implementation plans have mostly been submitted by now. SDSFIE-Q specifies overarching guidance for how the IGINS community will implement a tiered approach to quality, including data quality processes, measures, and metrics for their vector datasets. This standard does not include a required schema or data model, and therefore is not registered in the DoD IT Standards Registry, or DISR, as a traditional IT standard would be. Instead, SDSFIE-Q is modeled after the ISO 19157 conceptual model of quality for geographic data, and as such defines an IGINS data quality framework, with enterprise-level and component-level elements. When implemented with the other SDSFIE standards, this model for data quality ensures IGINS data align with IGINS mission requirements, conform to DISR mandates, and are understandable, trusted, and interoperable in accordance with DoD 8130.01. SDSFIE-Q includes a formal process for defining measures to assess the quality and completeness of data, as well as the reporting of metrics associated with these data quality measures using the SDSFIE-Metadata, or SDSFIE-M standard, and other applicable means. Adherence to the data quality guidance and processes in this document are required anytime IGINS vector data are created, updated, maintained, or shared. SDSFIE-Q also specifies data quality processes, measures, and metrics which apply to SDSFIE datasets individually in documents known as data content specifications. These technical documents provide essential information for data collection and metadata population. A DCS describes the ideal dataset, or how a dataset should be. In contrast, the actual state of the dataset and how closely it conforms to the DCS can be described in specific metrics, which are themselves defined in the DCS. DISD staff have created review batch jobs, or RBJs, that utilize Esri's Data Reviewer extension to quantify and report values for each of the metrics for an SDSFIE vector dataset. These values can then be inserted into the data quality section of the dataset's metadata, providing a valuable record of the state of the quality at the time of evaluation. SDSFIE-Q requires a DCS be created for each SDSFIE-V feature type, 266 in the most recent 4.0 Gold model. To date, DISD program staff have developed and published DCSs and corresponding RBJs for all 30 Common Installation Picture, or KIP layers, and an additional 39 SDSFIE-V Gold feature types. This diagram depicts the relationships between the particular SDSFIE standard, the corresponding resources on the SDSFIE portal website, and the action performed in ArcGIS. As covered in the model viewer generating a PDM video, the vectors standard is implemented to create an ArcGIS geodatabase with a schema compliant to a particular adaptation from the portal model registry. An adaptation is selected in Portal's model viewer, its PDM representation is generated in JSON format, and that file is imported into a blank geodatabase using one of the ArcGIS tools made available from the portal. Note that in addition to creating the SDSFIE-V compliant geodatabase, the Generate GDB from PDM tool creates metadata for all feature classes in the geodatabase, and by default populates their SDSFIE-M-based metadata fields to the greatest extent possible. It is also important to note that for several components, geodatabase shells compliant to a headquarters adaptation are provided outside of this SDSFIE portal-based workflow. Similarly, approaches to quality assessment and metadata development may depart from the approach presented here. Clearly, each component is encouraged to pursue the most efficient and effective pathways and processes to achieve compliance to the mandated standards. To reiterate, the quality standard is implemented both to provide guidance in the form of data content specifications, or DCS, that describe how the data records for the feature classes in the standardized geodatabase schema are appropriately populated, and to define quality metrics and provide tools to produce values for the metrics that then can be populated in the metadata of each feature class. All DCSs and each corresponding RBJ are made available through the SDSFIE portal. Again, note that the DCSs and RBJs address gold feature types. As described, the metadata standard is implemented as ArcGIS metadata styles that are unique to each desktop and pro version. The appropriate style is downloaded from the portal and then applied in ArcGIS. While this SDSFIE-M style is active, all SDSFIE-M defined fields are viewable through the description interface and accessible through the ArcGIS metadata editor. Any exported metadata records for SDSFIE-V feature classes will have a structure compliant to the SMIS. Finally, if the geodatabase was not created using the portal's provided workflow and the Generate GDB from PDM tool, or for some other reason the full entity attribute metadata information is not present, the Add Metadata from PDM ArcGIS tool can be used to add and populate some of the SDSFIE-specific metadata properties, namely the suite of definition, description, note, and justification fields not present in other metadata standards. These are the steps in which the suite of SDSFIE-M and Q products and processes will be demonstrated for a use case involving a building's dataset for a hypothetical Marine Corps installation. We will see where to get the ArcGIS metadata style packages and the DCS and RBJ for SDSFIE-V building. We will take a quick look at the existing building's metadata record through the SDSFIE-M style, see the detailed entity attribute information, and locate the quality portion of the record, where the quality metric values and supporting documentation will be inserted. We will examine the metrics in the DCS and select two dealing with dataset completeness, and then run the RBJs to obtain a report containing the values for those metrics. Finally, we will add and populate the report fields in the quality section with the RBJ output. The metadata for the Marine Corps demo datasets already contain the detailed entity and attribute information, so downloading and running the Add Metadata from PDM tool, steps 7 and 8, will not be demonstrated. We will start the demo with a look at the building dataset. This is the hypothetical Marine Corps base El Diablo, with the building and site datasets displayed in red and black respectively. Looking at the building polygon attribute table, we see there are 641 records populated. We find here foundational attributes characteristic of an SDSFIE-V dataset like building ID PK, the primary key identifier attribute, and the feature name and installation ID attributes with their alias names displayed. Also contained within the geodatabase is a mocked-up Real Property Asset Database, or RPAD, table. Opening this in a table pane, we can see that there are 715 building records with RPU IDs that should correspond to the RPU IDs in the building feature class. However, note that this number of RPAD records differs from that of the 641 building polygon records. This difference will be measured and reported on in our upcoming RBJ processing. Note also that if we check the metadata properties, we see that the style is set to item description, and that the SDSFIE-M metadata style is not present. We can also see that we are running ArcGIS Desktop version 10.8. Going to the SDSFIE website, note that we can get everything that we need from the standards page without being logged in. Starting with the metadata section, and given our known version of ArcGIS Desktop, we first find and download the SDSFIE-M 2.0 metadata style for ArcGIS 10.8 file. Scrolling down to the quality section, we find and download the KIP DCS documents, as well as the DCS general guidance, which contains instructions on running the RBJs. Scrolling down, we find that the building RBJ is in the Group 3 tool package, which will be our last download. To this point, there has been no need to log into the portal. However, if we would need to run any of the ArcGIS tools, for example, to add the detailed entity attribute portion of the metadata, then we would need to log in and access that download, as demonstrated in the SDSFIE Portal and Tools Overview video. After extracting the contents of all the zip downloads, let's first consider the metadata style zip files. Here we see that a setup executable is present. Double-clicking on the Setup Install Shield file initiates the installation process. After installing, simply closing and reopening the Esri programs is typically sufficient to access the new style. It should be noted that many users, and particularly those with government-provided computers, will not have the administrative authority needed to perform this installation. If you do not, please contact your component lead for further instructions. Opening the Arc Catalog interface, under the Metadata Properties tab, we see that the SDSFIE M2.0 metadata style is now installed and selected. Let's now examine the rich metadata content available through this style for compliant SDSFIE datasets. There's the 641 building polygons, and here is the metadata record for the building dataset, with all of the extensions noted previously. Here at the top of the record, we can clearly see the extended security constraint information, indicating that the metadata itself is unclassified and that the data for which the metadata was written belongs to the CUI category of DoD Critical Infrastructure Security, with dissemination controls limited to federal employees and contractors only. In the summary field, the SDSFIE-V building feature type justifications are presented, with the definition presented in the description metadata field. In the Entity Attribute section, we can view the extended content for the definition, description, note, and justification SDSFIE-V element properties. Looking at the content for the Media attribute, we can see the standard metadata field description contains the SDSFIE-V definition for this attribute, and the extended SDSFIE-V description, note, and justification tags and content as well. Finally, let's look at the Data Quality section where the output from the Data Quality Assessment will be reported. Here we see that I have pre-populated the Data Quality Report sections for DCS5 and DCS6, so they are ready to take on the values for the metrics that we will now prepare to produce. This is the building DCS, part of the bundle that we just downloaded. As mentioned, DCSs state how the standardized schema for the vector buildings data should be populated and what quality metrics should be assessed for the populated dataset. The DCS metrics are defined here in Table 4. For the purposes of this demonstration, we will generate results to create and report out the metrics for DCS5 and DCS6, which quantify the extent to which polygons are duplicated, an error of commission, and DCS7 and DCS8, the extent to which the RPAD records for buildings do not have corresponding polygons in the GIS data, errors of omission. All of the information required to populate the metadata sections for the data quality reports is found here, save for the reported values themselves. Note that the acceptable quality level for DCS6 and DCS8 are both 5%, which means that reported values less than or equal to 5% receive a pass for conformance to the metric. With this information in mind, we are now ready to run the RBJ for building. As mentioned, the DCS General Guidance contains instructions for running the review batch jobs in the Data Reviewer extension for ArcGIS Desktop. In Section 5.3, in the last bullet, we find those step-by-step instructions, which, now memorized, we will apply to ArcMap. Running the RBJs requires the Data Reviewer extension, which is packaged with the Production Mapping extension. If you do not have the license for Data Reviewer, contact your component lead to obtain the proper licensing. After turning on the Data Reviewer extension, we'll add the Data Reviewer toolbar. Next, we'll start a session by opening the Reviewer Session Manager. We've already created an empty Reviewer Results geodatabase and have that set as the Reviewer workspace. We will create a new Session 1 building session and close the Session Manager window for now. The next step is to indicate the RBJ that we want to run, and then pick the set of 4 metrics from the list of those available. Here in the Batch Validate interface, we will specify that all features in the building dataset will be examined by selecting the Full Database option. Then we will specify the building RBJ file that was downloaded. We are now presented with the full complement of DCS metrics that can be calculated in this batch job. As planned, we'll just run the DCS 5, 6, 7, and 8 processes. Once the batch job is completed, we will open the reviewer table to generate a report. The table contains the record-level results. As seen, there are errors. We need those summarized into a report with the dataset-level statistical values for our metrics. From the options, we can specify the type of report to be generated. For our selected metrics, the total record count report will give us the required values. After saving the Excel-based report, we can view it to extract the DCS values that we will insert in the metadata. The total record count report shows the consolidated error result for each RPJ check. The check title field displays the name of the metric pair assessed by the check. The name of the metric pair aligns to the metrics listed in the DCS for the feature type. On row 9, we see the results for DCS 5 and 6, the quantity of features with duplicated geometry. For DCS 5, we see that of the 641 total polygons, there are 14 features with duplicates. As reported, that is an accuracy value of 97.82%. For DCS 6, we need the percentage-wise error value, so subtracting from 100% gives us 2.18% of polygons with duplicates. Help me remember that number. It's less than the 5% maximum, so it passes the DCS 6 conformance test. For DCS 7 and 8, we see that there are 74 of 715 RPAD records that have an RPUID value that does not have a match in a polygon record. That error percentage is 100 minus the 89.65 accuracy percentage, which gives us 10.35% of RPAD records without a matching geometric feature. That's more than the 5% cutoff, so it fails the DCS 8 conformance test. Now that we have the required values from the report, let's go enter them into the metadata for our building feature class. Here in our catalog from the description tab, we can start editing the building metadata record. In the editor interface, we will select the quality section. As mentioned, the descriptive report information for DCS 5 and 6 has been pre-populated. The evaluation method type and description content comes directly from Table 4 in the building DCS that we viewed earlier. Here is the location to insert the value 14 for the DCS 5 metric into the metadata. We also need to set the date for this result. For DCS 6, we need to update the value, indicate that the conformance test was passed, and set the dates for both. Here in the conformance result, we'll set the date and indicate that the conformance test was passed. Finally, we will set the date and value for DCS 6. What was that percentage? Oh yes, thanks. Once we press the Save button, our changes are saved and the editor interface closes. We can see our updated values for the DCS 5 and 6 metrics in the SDSFIE-M compliant metadata. This ends the demonstration portion of this video. This concludes the Understanding and Implementing SDSFIE-Metadata and SDSFIE-Quality training. If you want to learn more about SDSFIE, its governance and use, or more detailed SDSFIE topics, visit our training resources page at the URL listed here. Thank you for your interest in SDSFIE.